Automotive Electronics Test 7. Dig that one out, get your pen ready, and we're going to talk about this. Now remember, whenever it comes time for final exams, you will have a open book final exam, but you will have to dig out the questions, and I usually set those up so nobody has any of the same questions on their test, and that kind of thing. So Automotive Electronics Test 7, the charging system of a vehicle equipped with an onboard computer-controlled charging system is undercharging. A lab scope connected to the ground side of the alternator field indicates a 90% duty cycle. Technician A says the alternator may need to be replaced. Technician B says the onboard computer may need to be replaced. Who's correct about that? Okay, now let's think about this. What are we talking about when we say a 90% duty cycle? What's the significance of that? What are we delivering that duty cycle to? Got any idea? The duty cycle is delivered to the part of the alternator that spins. The part of the alternator that spins is a magnet. It's a big magnetic field, those claws together. It's spinning inside that core of that stator. And that stator up there, look on the wall behind you up here. All right, you see this part right here? It's on the board. That's the rotor, and those two little slip rings are where your brushes go. Okay, that spins inside of this stator. This part moves, that part doesn't. And this is really close, like within 40 thousandths of an inch of the core of that stator. So as it's spinning, the strength of the magnetism in this part that spins is going to increase the output of the alternator. All right, the PCM is going to be looking at at system voltage. If system voltage is below the target voltage that the PCM is shooting for, it's going to deliver more of a duty cycle to that rotor. And if you deliver more of a duty cycle to the rotor, and it's still not able to meet its target, then you got alternator trouble, right? Typically, it says the alternator alternator may need to be replaced. The reason they said that is you can have a charging system volt drop issue and do that too. Okay, now remember, the part that's hooked to the pulley is the part that's magnetized, and that's the part that's spinning inside this rotor. And this part right here, let me show you this. Look at my thing. It's connected to the rectifier bridge, which has the diodes in it, and that's what takes the alternating current that's being created in these three windings here and turns it into direct current so it can be sent out to the battery. And the brushes on an alternator, when they wear out, they're riding on those little slip rings. You're supposed to have usually about 4 to 6 ohms of resistance on your alternator rotor. So you can have a bad rotor, you can have a bad stator, you can have bad diodes, you can have worn out brushes. There's a whole bunch of things that can be wrong with an alternator. All right, so just keep that in mind. Don't be afraid of that. The circuit that goes through the indicator light, your battery light, it goes through the indicator light and it goes to the I terminal on the voltage regulator, or it goes to, it'll be hooked to the alternator on some of them. The PCM on some of them, depending on if it's PCM controlled. That's what turns on the regulator. So if you're checking a charging system that doesn't work, the first thing you want to do is make sure that battery light comes on when you switch on the key. Not when you're starting it, when you switch on the key. If that battery light doesn't work, you better find out why before you throw an alternator at it. Is that clear? If the fuse has been pulled and that battery light doesn't come on, you'll have no charging. You'll have a good alternator. You can pull the fuse on some vehicles and it'll kill the alternator light. Like some of them have got a fuse that's just for the alternator light and one other light. If you pull that fuse or if somebody blows it horsing around, and the charging system is working, you can take it to a shop. Most of them will put one alternator after another on it and won't be able to figure out what's going on with it unless they understand how a charging system's wired up. Technician A says before performing a voltage output test, a visual inspection and preliminary check of the charging system should be done. Technician B says a voltage output test will indicate if the charging system is working properly. Who's correct on that? C. Before performing a voltage output test, visual inspection and preliminary check of the charging system should be done. How many are going to make sure all the wires are plugged in, the belt's good and tight if it's one of those that has to be tightened with a movable pulley, so on and so forth. Technician B says the voltage output test will determine if the charging system is working properly. You can actually check the voltage at your cigar lighter, and if it's up around 14.5, you know it's putting out. On a hybrid vehicle, if you energize that thing, and it throws the contactors together. It fires up the battery and feeds it to the system, and it goes through the DC to DC converter. It's going to feed 14.5 volts into the 12 volt part of the charge. You can go to the 12 volt battery under the hood, hook your meter up, and if you're seeing 14.5 volts, you know it's closed the contactors back there. It's another good thing you can do with that. That's just sort of preliminary check, but that's something you can do. Number 3, a 100 amp AC generator produces 105 amps all the time. Full fielding it produces 105 amps also. What's full fielding mean? You got power coming into one side of that part, that spinning part I was talking about. The PCM or the voltage regulator, whichever you got, is going to deliver a pulsed ground to the other side. It's going to deliver more ground when it needs more. Okay, so if you full field it, you're actually putting a dead short to ground on the control side of that field, which is the part that's spinning, the rotor. If you full field it, and you know it's easier to full field some of them than it is others. I can show you how to do it on the Ranger and the Sable. But the full field that is doing everything it can do when you full field it. That's when you'd have your inductive amp lead from your charging system machine hooked around the wire, leaving the alternator going to the battery with the arrow pointing toward the battery, because you're wanting to see what's actually coming out of that alternator. So number 3, if you parse that question the right way, it's got a 100 amp generator producing 105 amps all the time. The regulator is running the AC generator at full field all the time. And that's possible when they start to fail. What components make up the AC generator field circuit? It's going to have a battery, a rotor, and a regulator. Right? The battery feeds power to the whole thing and is also being charged. The rotor is the part that spins, and the regulator is what's sniffing the current to see how much field you need to put to the rotor. Not really all that complicated. What type of voltage is the output at the bat terminal of the AC generator? Is it going to be DC, AC, 3-phase unrectified, or none of the above?
B.
What? 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 What?
B.
What are you saying?
C.
Are you serious? What comes out of your battery?
DC.
DC. You're going to have DC going back into the battery. Or are you just talking out of your hat or talking out of your hood? All right. A ground circuit voltage drop test taken on a vehicle's alternator indicates 0.965. That's almost a whole volt. Technician A says this could be a problem, or could cause a problem in the alternator's field. See, a ground circuit voltage drop test. This could cause a problem in the alternator's field current. Technician B says this could affect the output circuit of the alternator. Who's correct about that? Actually, both of them are correct. Here's a little example. I worked on a Ranger one time that came to me at the Ford place. It was overcharging. You know, it came in, it was pushing like 16, 17 volts. I mean, that's what I'm supposed to check. It's making the battery stink, boiling the acid out of it and all that kind of thing. So I managed to go to the big yellow wire with the white stripe that was going to that 3-wire connector that was feeding the regulator. That's the sense wire. It's also the wire that the regulator feeds power to the rotor with before it, you know, grounds it on the other side. And that thing was only reading about 12 volts. My system voltage, when I go to the battery, is reading about 16.5, 17 volts. But the actual yellow wire, where it's sensing the voltage, is reading 12 volts. You can understand why the alternator would think, we don't have enough voltage and I need to keep fielding, and it would just pegging everything out. We had a voltage drop problem on the circuit between the fuse panel and the alternator. Being able to find a problem like that separates the men from the boys, right? Okay, so that's C, both of those guys. Technician A says when testing the voltage output, if the charging voltage is too high, the cause could be an open field wire from the regulator. Tell you something else that can cause a problem like I was just talking about. If you've got a dirty engine block ground between the engine block and the battery, it'll cause it to overcharge sometimes too, and other problems obviously. Let's see, Technician A says when testing the voltage output, if the charging voltage is too high, it could be an open field wire from the regulator. I don't think so. Technician B says a loose or glazed drive belt could be the cause of too high charging voltage. I don't think so either. That particular one is going to be D. It's going to be neither one of those clowns. All right. Everybody getting anything out of this? You understand it more than you did before you came in here. So what's something you've learned that you didn't know before? What about it, Brian? You just learned?
I wasn't expecting a question.
Huh?
I wasn't expecting the 4.
What do you know? Can you describe the operation of an alternator now better than you could before? Yes or no? No. Well, you will be able to, because that will be your part of your verbal final exam. You know what I mean? Probably 50% of it. You'll have to explain alternator. Is that scary? Ooh, you better go to work on that, hadn't you? Okay, you need to be ready tomorrow to explain to the whole class how an alternator works and be able to answer all of our questions. Well, can you do that? All right then. Remember when you're taking speech, pretend you're in a speech class. All right. Let's see. Technician A says a shorted diode may be indicated by a whining noise. That's somebody who wants a little cheese with their whine, right? Technician B says a squealing noise may indicate a loose belt.
True.
What do you think? What do you mean true? What do you talk about that? This ain't true or false.
I mean,
He means
You ever heard a whining noise because of a bad diode? Have you ever heard a ceiling fan that would go going vroom, vroom, vroom? It's the same kind of magnetic resonance, and it's because of the diode. Diode will cause it a diode will make a noise, make it sound like a bad bearing. And there are belts. Give me that belt back there. Hand me that belt. It's behind you. Hand me that belt. I'm gonna say something while I'm thinking about it before I forget it. All right. Now this particular kind of belt right here, if you see a belt like this, now this belt right here is one right here just like that. See that shiny gator back looking belt? Look at there. I'm having a hard time focusing on that. See that? It's real shiny, it's real polished. One of those belts like that. If you ever are working on anything that's making a whining noise, it'll sound like a bad bearing, it'll sound like a power steering pump. All you have to do is replace this belt and put one on there that's not all shiny. And this one here is brand new. It was made like that, and it will make it'll make a horrible noise. Seen it a bunch of times. Now the people that manufacture this belt don't like for me telling people that, but I think they pretty well quit making them like this and they started going back the other way. You see the ones that have when they're new are fuzzy, those are good. They're not noisy, but these right here will just make a noise like you wouldn't believe. I've had people call me and say, I've changed everything, I put a power steering pump, all these pulleys are still making a noise, what do I do? I say, what's the belt look like? And they tell me if it looks like this, I say put a belt on it, and they do. Hey, they fixed it. Yes, sir?
It just don't, I mean, it still got the noise, like on that car there, but I mean, it's got something to do with the tires, like when I turn.
What's this mean?
I'm trying to think of a word.
Yeah.
I'm trying to think of, but like when I turn, cause this tire, the right front is bent, like bent in.
Yeah?
And then like when I turn, it's hitting the plastic parts in there, so I can't make a full turn. Like
Well, who bent it?
it was like one of
Has
those.
it got big ugly tires on it?
Now I'm buying tires right.
I mean, what I'm saying is it ain't got no big ugly dumb looking wheels on it, does it? Okay. Oh, well, you sound like you got some negative camber.
Yeah. Very bad.
That needs to be done, something done. It ain't hard to adjust it on that car.
So 8 was B or was it C?
Oh, 8 was actually C. All right, why should an AC generator never be operated open circuit? A, it could overcharge the battery. B, it could burn out electronic components. C, it could ruin the AC generator stator. Or D, none of the above.
See?
It could burn out electronic components because it will spike up like you wouldn't believe. What they used to do, the conventional wisdom years ago, was if the car was running and you wanted to see if the alternator was putting out, you would have to pull the battery cable off to see if the car died, right? That's not a good thing to do, right? However, how many of you guys, when you've been jumping off a car out here, if you jump the car off because the battery's dead, as soon as you unhook the jumper, the instant you unhook the jumper, the engine dies. Hook it back up. Now, sometimes that's because the adaptive learning is gone and your idle speed control and all that, and also the alternator is loaded, heavier that way. Now, if you take it off and the engine dies, and you pick it back up and start it up and you take it off, the engine dies again, you pretty good chance the alternator's not putting out if the battery's dead, right? You got that? I mean, that's just something you can check with your voltmeter and all that kind of stuff. How many output diodes does an AC generator stator with 3 windings usually have?
Okay.
Anybody know?
I'm gonna go with 4.
Well, if it's got 3 windings
8.
and you've got 2
Well, I was thinking,
per,
convert the DC, I thought a rectifier bridge had 4.
well, yeah, that's a valid thought process, but on the way that these alternators are, see that? Notice how they're all pointing the same way?
6.
It's got 6. And these right here will connect to your 3 windings on that stator, right? And basically, on this side over here and this side over here, this is gonna be the frame and the output of your alternator respectively. So, you got that?
Who was that?
Huh? Who do I hear out here? There are people in the shop? That must be my,
Who usually comes and drinks.
that must be him talking on the phone or something. All right. Okay, let me ask you this. Technician A says when testing the charging system, the state of battery charge is not a concern. Technician B says the battery must be checked first before checking the charging system. Well, who do you think would be right about that?
B. Big B's.
B, that's right. Curtis, that's right. Technician A says a scan tool may be used to fulfill some alternators. Technician B says a field current draw test indicates if there is current available to the field windings. Who's correct about that? That's both B, A and B. That's Charlie. You know, if the PCM is controlling the field, you can typically do that. Basically, why would you do that? Under what circumstances? I would full field the alternator with the scan tool just to see what it was capable of putting out in the way of amps. If it's a 105 amp alternator and you can't get about 60 amps out of it, you're going to need an alternator on there. What does increasing the regulator field resistance mean? Does it mean more current is desired? The rotor's turning too slowly? Less output current is desired?
C.
A.
That's actually going to be C. Yep. Technician A says when testing, the ground side voltage drop should be less than 0.2 volts. Technician B says the total insulated system drop should be less than 0.7 volts. Who's right about that? That's C. Actually, the conventional wisdom I've heard was that 0.1 volts all you're wanting on that side. But that'd be on the charging system, you know, rather than the starting system. Where's the output of the AC generator created?
Stator.
Yeah, they give that man a cigar. He's right. Technician A says the regulator is the cause if full fielding the regulator bypassed, if full fielding with the regulator bypass produces lower than specified output. I mean, this is sort of a confusing wording right there. What do you think? The regulator is the cause if full fielding the regulator with the regulator bypass, which you're actually bypassing the regulator when you full field it. Technician B says a full field test will isolate the problem if it is in the AC generator or the regulator. That is a B. Now, I had a motorhome one time, and whenever I fired it up, I had the charging system tester on. It was overcharging. You know, they were seeing it on the gauge in there. And so it was idling, it was just fine. But if I gave it some throttle, it would full field. I mean, it would full field itself if I gave it throttle. And so I pulled the alternator off, went to the trouble to put a regulator on it, put it back together and did the same thing. What do you suppose was wrong? We had no voltage drop on the charging system whatsoever. The regulator was not the problem. We had the proper voltages everywhere we were supposed to have them. But it never, I mean, whenever I gave it applied throttle, it would go to full field. Somebody talk to me. Think about it. What's changing when you apply the throttle? What's changing? I'm looking for answers from some of you guys. What's changing when you apply the throttle? What's different when the throttle is applied than when it's idling? That can be related to the fielding of the alternator.
It's using up more power.
No, you're not actually using more power, you're generating more power. The obvious answer is everything's going faster. Okay, so how big is the pulley on the front of the crankshaft? You've pulled them off. How big are they? Give me an example. Yeah, probably 9 inches, 10 inches in diameter. How big is one on the alternator?
Like 4.
Tiny. It's a tiny little thing. Okay, so the alternator is really ginning up some speed. You got that big pulley down there. If it's spinning 2,000 RPM, and it's only a third, you know, you're spinning 6,000 RPM on the alternator. Okay, what's going on inside the alternator? We have centrifugal force. And on that peculiar situation that I had, centrifugal force was full fielding that rotor. And he called it too. It had a short that was happening when it was, and that's something I've never seen but about 2 times in my whole career. And I've been doing this for 40 years. All right, now then, Let me see,
70.
which one you got there? Okay, 15 was gonna be, let's see, in 16, we decided that was B. What devices are used to rectify current in an AC generator?
Diodes.
Diodes. What component carries the magnetic field current in an AC generator?
The brushes? Or is it
Well, the brush is actually sort of, that, yeah, I would, yeah, I don't like that question, because I would be, carries the magnetic field current.
I guess
That's, yeah, see that? I mean, that's a screwy question, because the brushes are actually what supplies current to the rotor, and I can see why you'd answer it that way, but the test writer, he wanted the rotor to be the right answer to that question. But I would be, if that was an ASE test, and some ASE questions are like that, I'd be thinking, wait a minute, it depends on how you're looking at it. So a lot of times on the ASE test, you gotta figure out what it is they're wanting, instead of what you've seen in the field. Sometimes what you've seen in the field will trip you up. Technician A says a diode should be tested with a digital multimeter that has a diode test setting. Technician B says when testing a diode with a digital multimeter that has a diode test setting, the meter should read approximately 0.6 in one direction and 0 when the leads are reversed.
both.
Both those guys are right. In a full hybrid electric vehicle, which component is responsible for recharging the 12-volt battery from the 300-volt direct current system?
B.
What?
The belt-driven generator.
No, it doesn't have one.
Or control.
C.
That's going to be the DC to DC converter. That's right. That's how that works.
All right.
Sir?
18.
Well, you want to listen? What's up with that?
We never did emissions last week.
Huh?
We never did emissions